Hi guys, Kishikawa-san's talk was incredible, wasn't it? After hearing it, I bet you're thinking, I want to try embedded system right now, right? Okay, let me show you some ways. You can start right here, right now. One way is to use a microcontroller simulator. I use Wokwi. Wokwi is a powerful online simulator that supports Raspberry Pi Pico, ESP32, Arduino, and more. You can also add buttons, LEDs, sensors, and lots of other components. Look, I just ran one of Kishikawa-san's projects on Wokwi. You can upload the firmware you built like this. It even had a VS Code extension, so you can build and test quickly on your Mac. With a simulator, you don't need any microcontrollers, electric parts, or soldering skills. You can try it right here, right now, for free. If you are passionate about programming real hardware, the Raspberry Pi Pico is my top recommendation. It's cheap, powerful, and you can buy it anywhere. I also recommend these two boards with ESP32C6. All of them cost around 1,000 yen. Over 99% cheaper than an iPhone. Compared to how many iPhones we have, it's almost nothing. With Embedded Swift, you can also develop for game consoles like the Playdate and Game Boy Advance. These devices can be expensive, but best of all, they all have free simulator and emulators. Here are some Playdate projects running on the simulator. And these are the GBA projects that Kome-san and I made. Of course, these run on your GBA like this. Game Boy Advanced programming is really fun. You should give it a try. You can check the supported target for Embedded Swift like this. If your device matches any of the target listed here, you can probably program it with Embedded Swift. And look, if macOS is on the list. The official documentation said Embedded Swift enables development of bare metal, embedded, and standard software. Yes, that's right. Embedded Swift is not just for embedded devices. When you build Hello World on your Mac, it depends on the Swift runtime. But when you build it in Embedded Swift mode, it still runs perfectly on your Mac. And the Swift runtime dependency is gone like that. The only dependency left is putchar. So this means you can write an OS or kernel with Embedded Swift. Here are some projects which build an OS or kernel in Embedded Swift. Last one is Wasm. I think you already know that you can write Wasm in Swift, but you can also do it with Embedded Swift. Of course, there are less things you can do compared to normal Swift, but the binary you build gets smaller. So it was trying. To summarize, there are many easy ways to start embedded Swift right now. So the only thing left is just do it. Enjoy embedded programming. Thank you for listening.